Okay, so this is a little linking video into what we're going to do next, which is dividing using the grid method, or using a grid to help us to divide. So if we took this problem, what we've got are 24, and we have 24 unit cubes, unit squares in yellow there. And we have to create a rectangle using those 24 such that the rectangle has one measurement of 3. So the length or the height or the width of this rectangle is 3. So let's start to do that. You can see now that we have used up all 24 and we have a height of 3 and a length of 8. Now with good multiplication knowledge and recognising that this is a very small type of grid, we know that 3 times 8 makes a 24. And what's interesting about this is that our sort of modern culture, if you like, would present the problem like that. So we only use 2 lines of the rectangle grid that we were originally presented with. So all division problems are really area type problems where we have a fixed height or a fixed length. So in this case, the fixed measurement was 3 and we had to create the rectangle of 24 cubes with a height of 3 to work out that the answer was 8. So like I said at the start, this is a video that is linking division into our area or our grid model, so we can extend our reach, we can extend the extent of numbers that we can work with, so that we can develop our skills working forwards and backwards using the grid method to multiply and divide. So if we took this, we have here 152. Okay, I'm going to exchange the blue 100 square into 10 of those 10 rods because those are easier to work with. So the problem that I'm going to ask here is 152 divided by 4. So let's look at that from this purely visual perspective. So I'm going to create a rectangle using all 152 and make sure that we have a height of 4. So we have along the left hand side here a height of 4. So I'm going to say that that is one set of 4 tens. This is 2 sets of those 4 tens, so 2 sets of 40. Here we have now 3 sets of 40. Okay, so if I start to think about this in terms of the grid, I know that the inside of the grid needs to add up to 152. So I've just used 120, and I know that that was 30. Okay, I had in total there. Okay, we had 3 sets of those 4 tens. Okay, so 4 times 30 makes 120. So we can work it backwards. I've used 120, and I know that 4 times 30 is 120. Okay, so we still have got 3 tens and 2 units. So to make this easier to work with, I'm going to exchange those 3 10 rods into 10 of those unit cubes. So each one of those 10 rods is now 10 units. Just to make it easier to work with, we keep creating the rectangle with a height of 4, and we can see here that that would be 8. Okay, and again, 4 times 8 is 32. So 152 divided by 4 would be 38. Now, we could think about this purely using the grid and build it up. So for example, I know that 4 times 20 would be 80. Remember, the white section of the grid here needs to add to 152. So there's the 152, and I'm going to keep a little running total of how close I am getting. So if I subtract that 80 that I have used up, I've still got 72. So in this space here, we've still got 72 to create and to use up. So let's say I use up another 40, because I know that that's quite a straightforward, easy pair of numbers that I can put in here, because 4 times 10 makes 40. Okay, so that means I've got 32. So I know that 4 times 5 is 20, and I've still got 12 to use up. and 4 times 3 makes 12. So what I've done is I have purposely, in the red here, thought about and used numbers that are in the 4 times table that will help me build up the picture and get a total of 152. Therefore, 152 divided by 4 is 38 because we're adding up the top row of the grid in grey here. Okay, 20, add 10, add 5, add 3. So my next question is, can we be more efficient? Okay, can we use less columns in this grid, for example? And the answer is yes, of course we can. Because I know that 4 times 30 is 120, we can create a little running total. So I need to use up all 152. I have currently used up 120, which means I have 32 left. This works out really nicely because that 32 can go into that grid space, because I know that above it I can put the 8 because 4 times 8 is 32. And that's a more efficient way of doing the previous problem where we used 20, then 10, then 5, then 3 along that top row. So we can create and complete division problems using the grid method and working it backwards. So you can pause the video at this stage and try this question. Okay, so I know that 4 times 20 would be 80. I need to work out how much I have to use, and that would be 36. And again, that works out really nicely. I know that 36 is in the 4 times table. 4 times 9 is 36. So 116 divided by 4 equals 29. And the next challenge that we could pose, of course, is can you make another question where the answer would be 29? And you can think about how you could use the grid method in a more creative way so that the top numbers are 20 and 9. 132 divided by 6. Well, a good place to start might be 120 because I know that 120 is in the 6 times table and it's 6 times 20. That means if we check our running total, I have 12 left to use up. I know that 12 can go into the grid because 6 times 2 equals 12, so that works out perfectly for us. Therefore, 132 divided by 6 equals 22. So you can try this next question and see if you can make another that would give the same answer. Okay, so thinking about my multiples of 6, we want to really keep the general structure of the grid method. So we quite like to have tens and units in those two columns. So I could try 6 times 10, 6 times 20, 6 times 30. Now 6 times 30 won't work because that would be 180, which is too many. I've only got 162. So we're going to do 6 times 20. Okay, checking my running total means that I have 42 to use up. And luckily 42 can go straight into that grid because it's a multiple of 6. 6 times 7 is 42. Therefore 162 divided by 6 equals 27.